Welcome to Brain Vision.
Okay, this is question 586, traffic court. We are called as an expert witness in a trial for a traffic violation. The driver slammed on his brakes and came to a stop with constant acceleration. And he locked his car wheels, and then the car traveled 192 feet before stopping. And then we know the coefficient of kinetic friction between the road and his tires. So he was charged with speeding in a 45 mile per hour zone, but pleads innocent. And we're trying to determine whether he's guilty or innocent. So essentially what we want to figure out is what was his actual velocity before he slammed on the brakes and then decelerated at this constant rate due to the friction force. So to do that, we're going to need to figure out what our actual acceleration, what his actual acceleration was first. So to do that, we're going to use Newton's second law. So let's think about the sum of the forces in the x direction, since the car is going to, let's just say it's moving in the x direction. So the forces acting on the car, since he's already slammed on the brakes, are just going to be the friction force. And the friction force is going to be negative because it's going to be opposing the direction of the motion. It's going to be slowing down the car, and that will be equal to the mass times the acceleration. So we're going to get a negative number for the acceleration here, which indicates that it's decelerating. So the frictional force is going to be equal to the coefficient of kinetic friction times the normal force. And the normal force here is just going to be mg because the car's weight is the only thing, the only vertical force that we have here. So when we want to solve for a here, so we can just simply conveniently cancel out our factors of m, and we're just going to be left with a is minus mu k times g, which will be minus 7.35 meters per second squared. Again, it's negative because it's decelerating. So now we want to figure out what his initial velocity was after he's traveled 192 feet. So to do that, we're going to need our kinematic equations. So let's say our final velocity is the initial velocity plus 2 times a times the distance. So we're given the distance here in feet, which is not completely convenient because we have everything else here measured in meters. So we want to convert this to SI units. So to meters. So if we use our unit conversions, we're going to find that this distance is equal to 58.5 meters. So that's what we're going to want to use here instead of feet. So we have now our distance here, and we just found our acceleration in meters per second squared. So those units are going to be correct. And we know that the final velocity here is going to be 0 because it's coming to a stop. So we're going to have 0 here. And then we want to solve for the initial velocity. So we want to solve for our initial v0. But remember, our acceleration is negative as well. So if we rearrange this equation like this, then we can use the absolute value of a here, 7.35 in our calculation here. So we don't have to worry about the negative sign. So now if we plug in d as 58.5 here, we should end up with this equation, and this will give us when we take the square root of both sides, this should give us an initial velocity of 29.3 meters per second, which when we convert this back to miles per hour is going to be 65.5 miles per hour, which is much greater than this 45 mile per hour speed limit. So he is definitely guilty.